As we continue this conversation about the law of cosines, we are going to digress just a little bit and use a formula that's often associated with the law of cosines to find the area of a triangle. And this formula is called Heron's formula, or sometimes it's called Hero's formula. And it's very handy because you use this formula when you have all three sides of a triangle. In the past, we've used some formulas that require us to know the base and the height, or an angle measure and a couple of side lengths. This time, all we need are all three side lengths. So you can see why that might be very useful. Let's jump in and try it. So back in our grade school days, we learned that the area of a triangle could be found fairly easily if we knew the base and the height of the triangle. We would use 1/2 the length of the base times the height of the triangle to find its area. But not always is that possible, as we may not know one or the other of those things. And so this is where Heron's formula is quite useful, because we can use this formula if we know only the side lengths of a triangle. Heron's formula is the area of a triangle is given by the square root of s times s minus a times s minus b times s minus c, where s is the same as the semiperimeter, which means half of the entire perimeter, which is the side lengths A, B, and C added together and divided by 2. So in this formula, S is the semiperimeter, and A, B, and C are the lengths of each of the sides. So let's see what we can do with this. Let's say we're given a triangle, and we're asked to determine its area if we know that the side lengths are 13 inches, 19 inches, and 24 inches. And we are going to use this to and find our area, rounding it to the nearest tenth of a unit. Actually, it'll be a square unit. So let's see what we can do. We know we're going to need S, so let's go ahead and calculate S. S is equal to A plus B plus C divided by 2. And in this case, 13 plus 19 plus 24 divided by 2. And that will equal 56 divided by 2, also known as 28. So now we can go ahead and substitute our S, our 28 in for every instance of S, and our A, B, and C side lengths in the corresponding places. So our area is going to equal the square root of 28 times 28 minus 13 times 28 minus 19 times 28 minus 24. So let's go ahead and simplify what's in each of those sets of parentheses. And so our area will equal 28 times 15 times 9 times 4. We'll go ahead and multiply those together, and we'll get the square root of 15,120. Then we will take the square root, and we will get an approximation of about 122.96 square inches, which when we round to the nearest tenth of an inch will be 123.0 square inches. All right, so the next example, we are given a triangle that has a side length of 6 inches and 8 inches, and we know that the included angle is 32 degrees. Now, to use Heron's formula, of course, we're going to need the third side. So by using law of cosines, we can determine that third side. So we're going to go ahead and substitute what we know as B and C and angle A, and then we'll solve for side A as the missing side length. Okay, so subbing in 6 for B and 8 for C and 32 degrees for the measure of angle A. We'll be able to crunch this in our calculator, and we find that A squared is equal to 18.587. And when we take the square root of that, we get approximately 4.3. Now we know that that last side length is about 4.3 inches. So knowing that, we can go ahead and solve for S. So S will equal the side lengths added, 6 plus 8 plus 4.3, and then divided by 2. And we will end up with a semiperimeter of 18.3 divided by 2, also known as 9.15. And then we can substitute our S and our A, B, and C into our formula, Heron's formula. So the area is equal to 9.15 times the difference of 9.15 and 6 times the difference of 9.15 and 8 times the difference of 9.15 and 4.3. That ends up with the square root of 9.15 times 3.15 times 1.15 times 4.85. And when we multiply those four factors together, we get the square root of 160.75, which is approximately 12.7 square inches. So this is a little bit more involved when you've got to solve for the third side. Now, if we are smart, we may recall that the other area formula that we knew from working with law of sines required us to have two side lengths and the included angle. Well, if we remember that, we can use that area formula instead. And this formula is way more efficient in this scenario. So if I sub in BC and sine of A, I end up with half times 6 times 8 times the sine of 32 degrees, which will give me 12.7 square inches. Now, much more quick and efficient and much more easy. See you next time.